Sorry about that, folks. It appears we had a glitch in the system. There was a glitch in the matrix. Seems to be shaking a little bit more. Oop. Seems to be shaking a little bit more than I'd like, so I'll put it back in the big container. If it gets any more unstable, I might have to put it on the bigger concrete platform. The 6x12 cylinder sample. This is just a 4x8. Just gonna let that run for a few minutes. I'm going to monitor the voltage as well. As I suspected, we're probably going to have to sit the coil on top of it. We'll wait until we're done with this test. I really don't feel comfortable having my head so close to this thing, so I'm going to move it. Old man says, Ben, is this new stream? Yes. So our old stream crashed. We had to start a new one, unfortunately. We had a decent number of viewers, too. That was unfortunate. Hopefully some of them subscribed and will return. Hey, Joe, how you doing? Joe says there's some type of video distortion if you look closely also. Video distortion? Really? You talking about like some kind of interference with the electromagnetic field? Because that would be fascinating. Now, I don't have an ozone detector yet, but just in case, I'm cracking a window open because we are using a coil that is known to output O3. Usually you can detect it with your smell, but just in case, I'm going to crack a window here and stand next to it. So I'm going to be out of view. So Joe says, I wonder what it would do if you put mercury in the glass. That's interesting. I don't know. My immediate guess is maybe it might spin. We're going to eventually order some fair fluid and put it in the vortex. I know Daniel Nunes said that it won't spin, but I think he was talking about when using the Nunes method. I'm not sure, because in theory it is magnetic. And it should have some kind of effect. Well, we'll see. You'll have to subscribe and stay tuned for that. I grabbed some incense. This is something that I've been meaning to do and keep forgetting as well. I don't see anything happening interesting with the smoke. Oh wow, did you see that? Did you see that? Now what happened there was my system shut off. And the stereo amp receiver, since it's only rated for a certain amount of voltage and current, it should have been fine. It was only like half of what it it maxes at the gain. It's like maxes out at 62. It's only at like 33. So I was spinning that for what, like 5 minutes or so? You all saw it. It was running fine, and then all of a sudden, boom. Now, I wasn't paying attention to the multimeters. Maybe somebody could key me in, because you should be able to see the numbers now. Maybe somebody can clue me in as to if they were climbing or not. Because that's interesting. If they were climbing, that makes sense. You know, it's building, it's building, it's building. It's getting within resonance, and all of a sudden, bam, it's within resonance, maximum spike in the output, and then boom, shuts down the receiver because it's getting too hot or too much power going back into it. That's interesting. Okay, we're going to turn it back on. Give me 1 second. We're going to keep it at 30. And then when it starts building up, I'm going to slowly decrease the gain. Just slightly. Hopefully that'll be enough. Because remember, we have to have a certain amount of power going in order for this to kickstart the synchronicity effect. So we're going to bump it up to what it was. Give it a little kickstart. Let it run for a minute, and then we're going to slowly decrease it on the gain. Alright, I just lowered it 3 notches. It was at 33 on the gain. Now it's at 30. It's still spinning. Didn't seem like it reduced in RPM at all. Let's see if we can decrease it a little bit more. 29. 28. 27. And it's still spinning like that. Wow. Okay. 26. All right, we're going to leave it at 26 for now for a minute and see how low we can get it. See how low we can go. How low we can go. That hasn't reduced in RPM one bit. It's still spinning at the same frequency because, you know, it's at a specific RPM. You can hear that frequency. It's a ringing. Hear it? Only it's 1 octave higher than that. I believe that's a G. I don't have perfect pitch, but I believe that's a G. But you can hear it. So as long as it stays at that same note, it's not reducing in RPM, in my opinion. You can't hear it reduce at all. It doesn't look like it's visually reduced at all. I don't know. I could be wrong. Again, I could be wrong. But so Joe says X2 and spin 2 tubes of mercury in different directions. Yes, that will probably produce some kind of an anti-gravitic effect, I can imagine, based on the Vedic texts in the Vimanas and how they worked. Make a set of coils where the mercury tubes sit in the center and spin in different directions. We need to be able to see the vortexes spinning and tune the patterns based on cymactics. Yes, Joe, yes, this is exactly right. You tune based on cymactics. I discovered the same principle. Using just a preliminary cymactics test, you can see how we can tune the coils visually with cymactics. Yes, 100%. The extra credit for today's stream goes to Joe. Very good, Joe. Very good. We're all on the same page. Yeah, sounds about right. Be back soon. Have to barbecue. All right, Nathan. Well, enjoy your dinner. Don't let me keep you from your meal and family. I appreciate you tuning in. Joe says you could paint a pattern on the bearing and use the RPM meter on it. Yeah. You should check out Cymactics frequency map for hints at trying certain frequencies. Yeah, I'll try to do that. That's interesting. I should set up a future stream for a proper cymatics test for sure. Good idea, Joe. I will be on top of that. So we were at 33 on the gain when it shut down. It's building, building, building. Let's turn back on our multimeters. We're at 26 now. We lowered it to 26, and I'm going to try to lower it even further. Let's see. 25. Didn't sound like it reduced at all. 24, and that's the cutoff. See, it just cut off just like that. No synchronicity. Wow. Okay, so we have a cutoff. We have a threshold. This is big news. This is very big news. Let's start again. We'll get the neodymium spinning fast, reduce it, and then keep it right at 25 and see. Okay? All right. This is cool. I like this. All right. We brought it back up to 33. 33 on the gain. We're going to reduce it a little bit. Remember, first time we reduced it to 30. I don't know. It sounded like it's picking up. Just slightly. It's hard to tell. Definitely ringing at that high G. Okay, we're going to reduce it even more. We're at 27 on the gain. Remember, we're going to keep it at 25. Try to see if we can keep it at the lowest possible. We're doing this a little bit faster, so I'm hoping it's built up enough synchronicity so far so that I can reduce it that much. Remember, we had it spinning a little bit longer than this before. So we're going to spin it down to 25 cutout. Okay, so we'll leave it at 26. Let's bring it back up to 33. I want to grab this just to make sure it's stable. Okay, it's pretty stable. Let it spin for a minute. Actually, let's bump it up to 34. Let's give it 34. Let's let it build up a charge for a good minute. And I think we're just going to throttle it at 27. We'll try to throttle it back to 27 and see how it works from there. And see how it handles it. Okay, I reduced it to 30 from 34. We got 3 more increments we're going to reduce it to on the gain before we let it throttle. $29, $28, $27. Okay, still spinning. Good. Okay, we're going to let it spin and continue to build out that charge. I'm not sure what the amperage is right now. We're monitoring the voltage at the moment. My multimeters will blow. I think there's more than 600 milliamps going into this thing right now. Doesn't look like it's increasing much in the voltage. Looks relatively the same. We're going to give it a few more minutes here, see if anything changes. Then we're going to move on to see if we can finally detect our magnetic monopole, and I'll actually demonstrate to you how the Nunez method works. For some of you who aren't aware of the Nunez method, and also the do-it-yourself guide for this coil I put up a while ago. It is available in the link in the description. You all can try this for yourself if you are a professional, or you're with a professional, or you're very safe around high voltage equipment. I must emphasize this equipment is dangerous, so wear your PPE and know what you're doing. Please do your research before you even touch this coil. But the guide's there. Anybody wants to do these experiments can do them themselves and replicate them. That's what I'm hoping for. And if you can't, that just proves there's something anomalous with my coil, which doesn't add up, because this is doing everything that the coil is supposed to do based on the inventors themselves. So let's give this a few more minutes here. We're going to let this spin up and build up a little bit more, and then we're going to move on to the monopole test and the Nunez method. All right. Yeah, Buddha. Mind-blowing stuff. Place your meter to meter amps using a shunt bar. I'll have to check that out. I don't know what a shunt bar is. AG alloy wire coil might be interesting too. Yeah, I'm not sure what that is either. Interesting comments, everybody. A lot for me to look into. Thank you very much for all your support. I really appreciate it. I will be having printouts of the Nunez method open circuit as poster form, framed, if you would like. This is the Nunez method. We'll be getting into this in a minute. I'll show you a little bit more of that. And I'm going to be selling printouts for anybody who wants to support the page and get a cool little poster to hang up on their workbench, near their workbench or whatever. And also, we also already have a whole host of amazing merchandise for you to choose from. And by doing so, you support the page, you give us the funds we need to further our research with the coil here, and you get something cool. So, win-win there. Anybody who's looking for a cool t-shirt or a mug, head on over to beneficencetv.com. And you can also find the merch link, directly in the description of this channel. still spinning pretty fast. Same speed it looks like. Alright, had enough of that. Let's try to detect this monopole. Alright, yep, we have time for just one more experiment, then I'm going to close it up. We'll try to get this monopole. I'll explain the Nunez method real quick. Oh, sorry. I'll do one more test. Then with the Nunez method, I'll try to detect the monopole that way. I'll explain the Nunez method open circuit. It is a method of maximizing your resonance within the coil there. Let's see what Mike has to say. Yeah. Jewelry shops have mixed rare metals in powder form. You can make good protein exchange membrane with those powders. Interesting. Yeah, I'm not too familiar with material sciences. I suppose that's something I'll have to get more accustomed to. Don't worry, I'll grab the camera and zoom in when necessary. It's our digital pole detector there. Grab a magnet so you can see. So that's the south pole, that's the north pole. And remember, if you have been following my research and watching my videos, the time that I could capture the magnetic monopole, it was only the south pole. It was not the north pole, indicating only outflow instead of inflow. Right. So for this system, since we're only utilizing 11 to 11 ratio for the wires in each channel instead of 12, which is what the PoE tutorial calls for, we are going to be resonating a little bit higher, around 21,050, I believe it was, or 20,050, something like that. So instead of the 12 hertz to 18 kilohertz range you see here, we're going to be going a little bit higher than that. And as you'll see in a minute, we're going to be hooking up, basically crossing our tone generator wires, the outputs from the stereo receiver. One's going to be hooked up to channel A, one's going to be hooked up to channel B. The first one, the positive, is going to be hooked up to the start of channel A, and the negative is going to be hooked up to the finish. So it's crisscrossed, and it's interesting because that means the only direct line for the electricity is through the load itself, which is very unconventional. If you've ever paid attention to Gerald's research, he notes that he's utilizing at least seven unconventional methods of building a system that mainstream science and schools will teach you not to do. So, for instance, putting two capacitors close to each other where they kind of feed off of each other. That is taught in mainstream engineering as a no-no, but ignoring stuff like that, maybe being open to the possibility that there are other options out there and that we do not know everything, we can basically, I think the quote is, and this kind of sums it up beautifully, once you're open to the impossible, you just might find the truth. And that is true. Once you've eliminated the impossible, whatever's left, however improbable, must be the truth. So we're shutting off the system. Going to stop the tone generator just to ensure we don't accidentally shock ourselves. This is an electric boom. I'm not here for your entertainment in shock value. Pun intended. Alright. As you'll see, the start of channel A is hooked up to the positive of the tone generator. So the positive, the red wire here, again, I have everything color coordinated for your convenience. That is hooked up to the start of channel A, so basically the same way we would hook it up normally. Now here's where things get interesting. The finish of channel A is hooked up to the positive of the load. And the positive of the load, as you know if you followed my guide, is the yellow right here. Here, let me zoom in for you. This will be better. Okay. So, this is the positive of the load. This is going to be hooked up to the finish of channel A, like so. Alright, now we move on to channel B, the second coil you see on the diagram to the right. The start of channel B is going to be hooked up to the negative of the tone generator. The black wire the finish of channel B. My apologies. So the finish of channel B is green right here. Again, start, finish, start, finish. The start of the bundle, the end of the bundle when you wind it around the frame. Now, the last wire left is the start of channel B, which gets connected directly to the negative of the load, which I have in my guide and in my system here colored as green. Let me grab it here. So as you can see, the positive of the tone generator is hooked up as normal. The negative, the black wire of the tone generator, is hooked up to channel B's finish. Interesting. And then we move on to the load. The positive of the load is on the opposite side, the finish of channel A. And the negative of the load is hooked up to the start of channel B. This is a very unconventional way of hooking it up. And as you'll see, it does power. And we can actually monitor the current as well, but the voltage, it does times it by 10. So it's very minor because I have to turn it down because it shuts off the stereo at a certain point, but it's incredible. And we're going to be using this connection for now as a baseline for testing for the magnetic monopole. If we can't find anything, we might have to flip the coil upside down. We'll test the Nunez method, switch back to the conventional transformer method I've been using. I don't think we'll test it that way because I've already tested it multiple times. I didn't find anything. At that point, if it doesn't pick up with the Nunez method, we might have to flip over the coil, which I don't like doing, but I will for you guys. Oh, let's catch up with the chat here. Let's see. The secret of science is to ask the right questions, and it is the choice of problem more than anything else that marks the man of genius in the scientific world, Sir Henry Tizard. I don't know who Sir Henry Tizard was, but he was a wise man. Thank you for that, Joe. Yes, Ben, the load is in series with the two coils. Center point is load. Yeah. That must be it, Mike. I think that's a astute explanation there. You can make a controller circuit to oscillate the fields like a brushless motor. True. This could also be used for fine-tuning and experimenting. Also true. Very good comments here. Thank you, guys. Yes. I know. Don't worry. I take care of you. Let's turn the system back on. And we are going to increase the frequency. Remember, we were at the Schumann resonance, 7.83. We're going to increase this to 2050. It's either 2050 or 2150. To go really high to get any kind of effect. We're going to turn this on microvolts. Ooh, overload. I'll turn that down. Interesting. Not getting the 10 times voltage. Let's see. Maybe I'm on the wrong frequency. 2150. So far, not too much, but it increased a little bit on that side. 2200 hertz. Yeah, I'm not seeing any kind of 10 times. I did see it once. It was 12 volts on this side and 120 microvolts. 120 microvolts. Is it micro or milli? I always get those two confused. But it was 12 on this side and 120 on this side. Let me mess with it a little bit, see if I can get it. Let's change the frequency here. Go back to 2050. Interesting. That must be what it is. Yeah, that's it. Okay. Oh, did it just... what happened? Oh, okay. Well, what the heck? Maybe it's not high enough? I blew a fuse? Really? Oh, no, I didn't. Okay. I was gonna say, this is 10 amps. There's no way it's at 10 amps. That's weird. I must have blown a fuse in this one. Unless it's just not rated for that high frequency, that could be it. Let's try lowering the frequency, 60. Oh, there we go. Interesting. Got 16 millivolts on the input and 17 millivolts on the output. 2150. Let's go to 21 or 2050. Let's go to 2100. So the problem with these multimeters is they're only picking up accurately in one of the settings, and they only do so, and that setting switches depending on what frequency you're in. So I might not be in the right setting. Keep that in mind as well. But I'm trying to figure out how I did it, because I did get a pocket of energy at that high frequency range that was clearly more on the output. But in retrospect, maybe I was accidentally monitoring the amperage. You know, I'll check the amperage as well. It could have been the amps. Which would be very interesting, because that's not what's supposed to happen. Okay, so this is our regular resonance range. This is like our first resonance range that gives us the voltage multiplication. And we're not seeing it here, so we must have it on the wrong setting. turn up the gain a little bit. There it is. Turn it up to 23. Okay, see, here we have an exact 1-to-1 ratio. Almost exact. This is slightly higher. That's interesting. Let's try turning it up a little bit. 2.1 and 2. Yeah, see, the Nunez method in that original resonance range, remember, we're not using the traditional method that I'm using to get the 155% efficiency. That's doubling the voltage while maintaining the current. It could all, I have theories it might also be doubling the current as well. We just can't see it with the multimeter accurately. But that's besides the point. I digress. What we're seeing here is the Nunez method, which is not the method that I have been using to get over unity achievement, or achieving over unity. So our original resonance range starts around like 700, and it goes to like 1200, I believe. And then our second range is around 1800. We don't see that in the Nunez method, which is very, very unusual, but we are resonating it differently. We're not just resonating channel A and inducing channel A into channel B. We're resonating both channels opposite of each other. So we're feeding the channels opposite of each other. We're feeding channel A one way and feeding channel B the other way, creating more of a torsion field that, in my opinion, allows for the maximum absorption of the resonance. It's like, imagine a ping pong ball bouncing between two walls, right? You have the walls at a specific distance, and you have a specific frequency that is a specific frequency that is correlated with that distance. Ping pong ball bounces back and forth. If you open up those ping pong balls, or if you open up, if you open up the walls more and allow the ping pong ball to bounce, the frequency will be lower. If you close the walls in, the frequency will be higher, but you have less cavity. So that, I believe that's what's happening when you have an open circuit. You're allowing for more cavity. So basically, in retrospect, now that I'm thinking about it, you're changing the resonant frequency. You have to be, because you're opening that cavity up to more resonance. Mike says, be right back. Okay, Mike, I'll try not to lay out any spoilers for the audience while you're gone. Just FYI, we do have a new show coming on tomorrow at 6 p.m. Eastern Standard Time. That's 3 p.m. if you're over on the West Coast. It's going to be a fringe think tank, and we're going to have on one guest at a time. And the first guest is going to be, well, technically the second guest, because we had Gerald on the kind of like the experimental episode. So we'll have Mike Does on Monday. That's tomorrow at 6 p.m. Eastern Standard Time in our brand new show, where Nathan from Old Man Builds and I host. So I'm going to give up on the over unity aspect of this method in a minute and move on to what I originally intended to do, the monopole test. So I get very distracted. This coil is very amazing. There's so much going on with it. And to be honest, I do have a full-time job, and this is like one of the only times that I have to work on it. So keep that in mind as well. So Nathan asks, are you hitting resonance of just frequency? I think so. I mean, all I'm doing is adjusting the signal with the tone generator, pulsing it. So, but honestly, I can't say. You would probably know more than I would. Eventually, I'm going to build one for you and send you a coil and, have you test it out, and you probably would have a more thorough analysis of what's going on with this thing. But yeah, honestly, I can't say. As of right now, I know I'm just shaping the signal with a tone generator. So just shaping the signal that's going through the coil. I remember I had it on microvolts. Let's switch to microvolts. Oh, you know what? Let's try plugging it in. No, that's not it. Very interesting, but frustrating at the same time. Alright, where's my magnetic pole detector? Nothing from the magnetic pole detector. Let's try increasing a little bit. I mean, we do have slight increase in voltage on the output still. Nothing. Let's try 432. If anybody has any interesting frequencies they'd like me to try with the coil while I have you guys here, put them in the chat, and I'll try pulsing the coil at that frequency, see if we get anything interesting, any kind of interesting readings. So we've tried the Schumann resonance. Sorry, I have a slight speech impediment. Yeah, 432 is what I was going to try next. But the only two that come to mind are 432 and 7.83. So if you have any others that come to mind, 853. Okay, that's a good one. So we're going to start with 432. Oh, 864. Okay. No pole detected there. We're moving on to 864 hertz. No pole detected. Multiples of 432. Yeah. 1296. Okay, so next we're going to try 528 hertz. 528 hertz. Bam! Let's get that out of the way. Nothing. Nada. Not a single pole. No pole detected. Increase that a little bit. Oh, it's overload. There we go. I'm going to increase the gain a little bit. See if we can pump up the juice. No pole detected on 528. 1296. Yeah, that's true. You know what? That's interesting. Let's try DC power. Yeah, let's turn off the tone generator. All right, that's a good idea. Thanks, Mike. Thank you for that. That might have been what I was doing. No pole. But we can switch it. Let's switch it to the traditional method and try the same thing. Okay. See here, now I switched it to the traditional method. And if this doesn't work, we're going to flip over the coil and test the other side, because it very well could be the other side that I was testing too. Again, for those who are just catching us on this amazing live stream with my over Unity system, we are trying to figure out how my dumb butt captured a monopole with this system, and I ignorantly didn't record what I was doing at the time. I was just so excited with working with the coil. As a lot of scientists, I've come to gather now that I look back at my mistakes. So we're trying to recreate that and see if we can pick up the monopole again. And I have a feeling it's on the other side. I'm going to turn off the multimeter, save my battery some power for now. Mike says try pure tone files. Yes, I was trying to find pure tone files. I couldn't find an archive. So if you have one, or yeah, YouTube. I should just download or use the YouTube videos too. But yeah, if you have actual tone files, please send them to me. I'd like to, because I can throw them in a audio software and string them together and do my own frequency sweep that way. Nathan says I would play AC/DC Thunderstruck and see what it does. If I didn't get hit with a copyright flag, I definitely would do that, Nathan. Totally, for sure. I will. I can play some of my copyright-free tracks, some of the tracks that I play on my channel, which I like. I listen to. I bump to them. Ghost Beats is amazing for one. I listen to Ghost Beats a lot. And I have a theory. Ghost Beats reminds me of a ghost writer, so I have a feeling that Ghost Beats is a bunch of different artists, unnamed artists, under that label. Your humor is uncanny, Nathan. Oh, we all like to have fun. I know I like to have fun here. I want to see what the frequency does. Yeah, take a multimeter and change it to frequency. Well, that's interesting you say that, Nathan, because the multimeter does have the frequency built into the top. So once I get it going again, I can show you it does pick it up, but after a certain point, it doesn't pick it up anymore because it's not rated past, I don't know, like 3 kilohertz or something like that. But yeah, it's very convenient. It's like an idiot-proof multimeter, in my opinion. That's why I picked it. It's very good for what it does at its price range. It's not excellent. It's not ideal.
but it will suffice for now. And that's something that I'm trying to improve on, improving my equipment and increasing my testing, taking it to the new level. All right, what was I doing? Testing the frequency. We are testing the DC signal. So we're going to turn the stereo up back on, test the DC signal, see if we can pick up that monopole, and then we're going to flip over the coil and do exactly what we just did. Because science is about repetition. And you better get used to it. These things can be tedious, but I make them fun, hopefully. Right? We got 33 on the gain. Very nice, very nice. Ooh, online tone generator. Nice. What is the range on that thing? Quickly put in the range for me. I'll look it up in a minute, or I'll put it up on screen in a minute when I'm back at the workstation. Since I'm in the lab here, we really don't have access to the workstation, which is running the Streamlabs software. So it's kind of like I got to go back and forth to do that sort of thing for you. Don't have a producer. I am my own producer, director, writer, and I can't think of another one. Alright, 33 on the gain. Now, what did I do with my pole detector? There it is. No pole. Alright. We're going to turn on the tone generator again. Oh, shoot! There we go. That is spinning like a mofo. Oh, the light is on, so it's not dead. Thought it was dead. It was just the lighting in here and my poor eyesight. No pole detected. You know what? I'm going to flip it. I think this is fruitless at this point. I'm going to try flipping it. Because that's the one thing that I haven't tried in a long time. And to be honest, I only did it once. Turned off the tone generator for now. We're going to turn off the stereo amp receiver. Safety first, safety first. And we're going to very carefully disconnect the leads, because we don't want to damage them. We want this baby to last for a while. We're going to give it a nice flippity-floo. Here we go. Let's bring these down a little bit. Okay. Reconnect them all. We're going to first try the transformer connection, what we just had it on, basically where all the colors are lined up. The method that I use to achieve the 155% efficiency with the system. So the closed circuit method, the induction method, we'll try first. we are all set up. We got the coil flipped, hooked up, and ready to rock. Square wave is a DC pulse pen. Oh. So you're saying I should switch it to sine wave. That's possible too. That's another variable I did not consider as well. The waveform. What waveform are we on? I was on square wave. We might need to do sine wave. So that's something to also consider. Set it on square, drop it to 8. Oh, I see. You want me to drop it like it's hot. Okay, I can do that. Don't get upset at me if the pimps try to get at you. Drop it like it's hot. Drop it like it's hot. Hope I don't get flagged for a copyright 8 hertz. Yeah, you're using sine wave now. The stereo has sine wave output. So I'm actually using a frequency generator on the laptop. So if you look here, oh, I gotta hook up my camera to the battery real quick. So if you look here, I was on square with this. This is a frequency generator on my laptop. And that's going from there to the back of the stereo input. But yeah, I'm already using a frequency generator. The problem with this thing is that it's limited to 25 or 24 kilohertz. So I need to go a little bit above that, I think. Maybe that's it. Maybe I didn't go high enough on the Nunez method. Yeah. All right, that's what I get for not documenting this crap. That is why I'm having these live streams. So as I do these experiments now, I can document them this way. All right, we're at 33 on the gain. Flip the coil. We're going to pulse at 1296. Whoa, baby. Let's turn that down a little bit. No pole detected. Let's lower that down to 8. I'm going to go really low. How low can you go? Nope. You know what? Let's try switching from sine to square wave and try them both at the same time. Let's try that. So we're on square 8 hertz. Nothing. Try 800 hertz. Square. Nothing. 1000. Oh wait, let's try 800 sine. 800 sine. Nothing. Nothing. So we're going to move on to the Nunez method and see if that picks it up. Yeah, 20K is the highest I could find too. Okay, so let's disconnect it again. We'll try the Nunez method again with it upside down. And again, we're not going to change the red lead. Red lead goes to the red output. Or technically it's the input. It's the start. Since it's flipped, it looks like it's the finish, but it's actually the start. Don't let that fool you. And the output, the finish of channel A, is going to be the positive of the load, which is yellow. So the finish of channel A, the black wire, is going to be hooked up to the yellow. Channel B's input is going to be hooked up to the negative of the load,
right here. And the output is going to be hooked up to the negative of the tone generator. All right. And now we pray that we can find this monopole. Nothing. I have it at 24 kilohertz right now, the max range. Sine waveform. Let's try 24 kilohertz at square. Nothing. Huh. Okay, so we're going to go low. Remember, the strong electromagnetic field is generated at the low range, the low end of the frequency range. So go 8. Nothing. Nada. Not a single pole. Go down to 1 hertz. Dang, nothing. I'm going to turn off the tone generator. Nothing. All right, let's try 5 hertz. Nope. Shoot. I think we're only going to find the pole. Oh, we didn't try the low frequency range with the induction method. I think we're only going to find the pole with the induction method, because I believe, if I'm not mistaken, the original chart for the Nunez method that I pulled off of First Stop Energy does say, it's a little bit ambiguous. It says one of them has no poles, and one of the methods has a monopole. But that is a different method than the Nunez method. That is the one where they're connecting the bottom to the top. Let me take a look at that real quick. Give me 1 second, because that might be how I did it. Okay. So I think what we need to do is connect the end of channel A to the start of channel B. So the green wire is going to be connected to the yellow wire. All right. Okay. Got them connected. Turning back on the stereo receiver. We're at 5 hertz square wave, 32 on the gain. No pole detected. Son of a bee. Let's go back to 7.83. Very frustrating right now. I cannot detect this monopole. Maybe I have the circuit hooked up wrong. I'm going to take a look at that real quick. I'm going to go back to the workstation and let's take a look at that circuit real quick, that diagram. I might be hooking it up wrong. So let's do that real quick. Shut down the system. Mike says those battery-powered pole detectors are not so reliable. I use the real magnetic. Yeah, I mean, but unfortunately with this coil, you know, it's hard to detect that with the traditional. I mean, I do
to verify it is getting an electromagnetic field generated, use one of these bad boys. But there's an LED stuck to this. But it only gets you so far as to determining the monopole. Really, you need the digital pole detector, and this is a very cheap one. So yes, take this pole detector with a grain of salt, because we might be detecting one and just this pole detector isn't sensitive enough to pick it up, type of thing. All right. Oh, hey, Lenny. Lenny's shy sometimes.
Hello everyone, welcome to Beneficence TV Live.
Thanks, Lenny. So we're going to bring up that diagram. I believe it's in my Rodin coil guide. Here. All right. Hopefully y'all can see that. This is my Rodin coil guide. So this will guide you through the process, the exact process that I used for my system, the exact equipment. I do need to put links to the exact Amazon parts in some of these, so I will do that in the future, but I just get so busy. Anyways, we're going to scroll down here, and I believe it's in here. Okay, here it is. This is the method. Oh, I see what I did wrong. Okay, so we're just going to hook up the end of A to the start of B without the load introduced into either end. We're going to hook up the tone generator to the start of A. We're going to hook up the tone generator to the end of B. Finish. That's how we're going to produce our magnetic monopole. All right, people. I think we have our answer. Finally. Just took a little bit of free time for me on my part to do the proper research and rewind, go back over my footsteps and figure out exactly what I did. Because I'm sure I tested this at some point. I'm almost positive I did. going to leave that up so I can take a look at it. We're going to put that, switch to live stream. Oh, there, it's already in here. Okay, good. Beautiful. There we go. That way I can see it on my laptop, and you guys can take a look at it as well. All right, back to the lab. So what we're going to do is we're just going to take this yellow wire right here. I'm going to disconnect it from the output circuit, repurpose it as a connector between channel A and channel B. And leave that down here. All right. Let me just bring this up real quick and take a look at the diagram real quick and go over it just to verify. The positive of the tone generator is hooked up to the start of channel A. Okay. Negatives hooked up to the positive. Okay. And then the finish B is hooked up to negative tone generator. Yes. Okay. All right. We're going to try this. We're going to start at a low frequency. Let's try 7.83. The Schumann resonance. We've been having luck with that frequency. We're at 33 on the gain. No pole detected. Huh. Okay. Let's try sine. Oh. No wonder why. The tone generator's off. Okay. I should probably turn it on before I test it. Nothing. No pole detected. Let me... Oh, shit. Excuse my language. I'm sorry. I turned it up a little bit. Let's disconnect that. I don't want that to burn out. So I turned up the gain a little bit. We're at 40 on the gain. Just to see. Oh, boy. Look at that. We're actually detecting 2 poles. Woo! I blew the capacitor.
Yeah, buddy. That's why we wear PPE. Oh, wow. Look at that. Let me disconnect that circuit entirely. We're just going to disconnect that. Wow. We blew another capacitor, guys. But we did detect 2 poles. I've never detected a North Pole in this system. We're going to try that again. So we disconnected the reference circuit, so we're safe to test it. Oh boy. Oh boy. So I'm going to show you that. Let's do it close up. We're at 40 on the gain. See? It's detecting it. But look at it. It's a weird pattern. Unless it's just like a weird sensitivity. Oh, okay. So when you get closer to the center. See, look at that. It's actually detecting both the poles. I've never seen that in the system before. So let's see if we can try a different frequency. This is the Schumann resonance. Let's see if we can find a different frequency that will actually produce the monopole. Sine doesn't do much. It's actually better with square, so we'll keep it on square. Let's do 600 hertz. Square waveform. No pole. Well, let's go back down. We were having a look at the lower frequency range. Okay, 8 hertz. Oh, we're still detecting 2 poles. That's weird. That's really weird. Okay. And since, Nathan, this is an added bonus. Since this system is set up as the speaker method, we can actually test the speaker as well before we end the stream. Yeah, I'm still not detecting any monopole. I got 2 poles going on. Never seen that in the system. Again, never seen 2 poles. That's so weird. Because Daniel Nunes never detected. He said he never detected a North Pole. Ever. What the heck is going on with my system then? I'm almost positive this is the way I detected the monopole before. Could running the coil to such a degree maybe alter its properties? Is that even possible? Let's try a higher frequency. I'm gonna try 24. Still detecting 2 poles. 30 hertz. No pole. 25 hertz. Oh, wow. So look at that. 25 hertz. And again, the flipping between north and south poles is actually, the frequency between flipping is, it's not even. It's asymmetrical flipping back and forth in different, it looks like 2 different frequencies, and it looks like, I'll show you in a second, this is
It's supposed to be going back, forth, back, forth, back, forth. But it's like back, 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 forth, back, 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 forth, back, 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 forth. And then the higher I go, back, 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 forth, back, 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 you know, the more south I get. And look, at 25, we get a lot of north, and then a little, you see that? See that? Bop, 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 bop. So let's increase it a little more. Frequency of the North Pole increased. That's weird. How did I get that monopole? Maybe it's something wrong with the equipment. Maybe I just didn't hold down the button long enough before to see. Oh, this is really interesting. I don't know what the heck is going on here. Just when I think I know what's going on. Yeah, see now it's flipping back and forth at a weirder frequency. Let's try 1 and do 1. Oh, there it is. That, oh no, we got a north. What the heck? That's 1 hertz. Yeah, the microphone, I need to get one that clips to my collar. So I can't find this monopole. I keep detecting a north pole. That's not what's supposed to happen in the system, and that's not what I detected before. You know what? Let me try something. Let me try something here. Let me try using 1 positive from the right speaker and 1 negative from the left speaker. Same channel, channel A. We're just putting it in a different slot. So what I hear, I'll repeat that because I know the mic is a little, it's bad because it needs to be fixed. But what I did was, see right here, instead of plugging it both into the same right speaker, which is this all the way on the right, the black and the red, I plugged 1 into the right and 1 into the left speaker. See? Originally it was right here. I moved it right here to the left speaker. See if we get any effect with that. You know what? Let's switch it back to the Nunez method and turn up the gain because I didn't have it at 40. Remember, I had it really low. I think we need to turn up the gain at that. Okay, let's do that.
Let's unplug this too. I don't want to pop this again. Actually. No pole. No pole, 2 hertz. Go back to 7.83. Yeah, I'm not detecting any monopole. So weird. 24. Turn it up a little bit more. No. Alright guys, I'm going to call it on the monopole test. We tried, we got very close. I think there needs to be more research into the monopole effect of this system before we do any more testing with the monopole to determine where I found it. So with that, I'm going to close with a speaker test. We're going to do the speaker real quick and end the stream. All right. We have the speaker set up. We're going to demonstrate the speaker abilities of the coil. Probably not going to be the highest quality. As you can see, it's not exact parabola, which is what it would be ideal. And ideally, also, we would want 2 coils stacked against each other. So what you just saw there was I magnetized my pot. This was not magnetic before. Look at this. Oh, it's not. Okay, so we'll do it again. Oh, shit, man. Woo! Oh, wow. What the heck? Well, it stuck to the pot for a second. I don't know how I did it. I don't know if it caught it on camera or not. I hope it did. But it stuck right here. And I had to pull it out.
Beneficence TV Live.
All right, ladies and gentlemen.
Hey Tim, how you doing? Can you turn the volume up, max my phone? Yeah, so my microphone is stationary. I need to get a new mic that clips to my collar. Once I do that, it'll be fixed. So yeah, just I try to remember to pick up the mic when I have something important to say. At any rate, so closing statements here. Very interesting stream. Very, very fascinating stream here, because while I was not able to detect the magnetic monopole that I did before, I detected a North Pole, something that Daniel Nunes himself did not detect in his research. He specifically said that at the Breakthrough Energy Movement Conference in 2017? Yeah, and again, we'll probably watch that again at some point on live stream to go over it, just to be sure. But you know, I'm almost positive he said that he didn't detect the North Pole. So that's very interesting. Very interesting. Regarding the stereo speaker, I would like to do more tests with that. When I have the second coil wound, we're going to make a better quality speaker for sure. That's going to be fun. Something interesting that happened, though, and I did not expect this. The pot that I was using as a semi-parabola, better than the square pan I was using at least, but I was using a Teflon-coated pot, and I put the neodymium sphere in the pot, and I rested it on the top of the coil. And when I put it on the Schumann resonance, it was really high on the gain. It was like almost 40, I think, or maybe it was 40. It, starts spinning, obviously, like it's going to do, and it, like, I guess, bounced around a little bit, and it knocked the pot off of the coil, and it magnetized the pot slightly for a second. It stuck to the side of the pot, and I'm not sure how it did it. I'm not sure how I did that. If anybody has any insights on how that could have happened, please let me know, because that was crazy. We also witnessed the death of one of my capacitors, sadly. RIP capacitor number 347, something like that. But yeah, so that's why you always wear your PPE, safety glasses, and in this case I'm also wearing a hard hat, so make sure when you're doing these experiments you take the proper safety precautions. So surprises like that can be fun and not terrifying. With that said, I really appreciate everybody from tuning in. This was a really, really great stream. Really, really fun stream. We're going to have to do this again. If anybody is still watching, we do have a new show coming on tomorrow at 6 p.m. Eastern Standard Time, or 3 p.m. on the West Coast. It is called The Fringe Think Tank, and it will be hosted by Nathan from Old Man Builds and myself. We'll be having on Mike Does as our guest for tomorrow. So we're going to be getting into the Bendini circuits, the Bendini motor, and also talking about Phase 2 testing of my Rodin coil system, which includes a Bendini schoolgirl circuit. Yes, thanks for tuning in, Jalapeno. Thank you, everybody.
Thank you all very much for your support for our channel. It's been a great live stream, and I know I'll definitely be coming back for more.
Thanks, Lenny. Yeah, we gotta have Lenny back on the show. Let's give a like on this stream for everybody who wants to get Lenny back on the live streams. Enjoy the company, Lenny. Even though sometimes you're a pain in my butt. All right. Well, with that, good night, everybody. I'll see you next time.